Alrighty guys, I thought I would do a quick introduction on the game engine. Just one of the components of the game engine that really kind of does a lot of the work, to be honest. It's almost, I guess you could say, it's very similar to just a simple array, if anything. But it's kind of the bedrock of the kind of entity component system, whatever you want to call it. That underpins the engine at the moment. Will it change? Probably. Will it change a lot? Probably. But this is how it stands at the moment. And the cool thing is it actually does, it makes adding in things to the engine really simple at the moment. I don't know if we want to call it an engine or if more like a framework. But let's have a bit of a dive. So, if just looking at the code, just as an example of how I've set things up. Basically, like this is the actual kind of game code, and then obviously there's the kind of generic engine code that sits behind it. But if you have a look at the way that you set something up in the code as it stands, basically what you do is you have these what I've called elements. The way to think about an elements structure is it's basically just a table. So all I'm doing here is saying, okay, for the physicals table, add in for this ID, add in the physical structure for that ID based on like particular initial parameters. And you can do that for all the different tables. So if you got like your renderables, renders, and you just throw in the renderable components using the same function. So it's the cool thing about that function. It's although it's like C programming, it's kind of allows for different size structures in the third parameter here, and then depending on which table you send through to the function, it will chuck that particular components into that table. So what you have here is you're looking at the spaceship. You know, you've got a physical component to it, you've got a renderable components, you've got linear motion and an angular motion, which basically linear motion is just kind of your straightforward kind of go forward, go back kind of calculations. Angular motion is kind of your turning kind of calculation, so to speak. So if you have a force that acts on an object in a particular direction, you know, it can rotate the object. So all of those calculations are in what I've called the angular motion component, but all your kind of typical, you know, more normal kind of physical calculations are in the linear motions component. And then I've got this thing called trackables, basically like a camera trackable tag. So if so what I've got here, basically like if the camera will be able to track any object that has that is in this table. So if you've seen in some of the videos, the camera kind of moves from one object to another. It will only do that for whatever's deemed a trackable. And the nice thing about that is that then that table could be relatively limited, and then the camera only has to worry about like whatever's in that table rather than worrying about like your whole object list, which is kind of entity component system stuff, I guess. And then here you've got inventory. So I've just added this thing in. It's a new one for mining. So when a spaceship is like near an asteroid and mines from the asteroid, it fills up its inventory. Yeah, and then as you can see, like the camera will have a specific camera elements. I'll just call it elements to keep it a bit different to components, but it's all kind of the same thing. And then you see these are the drones, and it's basically the same thing, right? But here you also have an owner. You've got an AI component, what I've called brain. It's got its own inventory slot, and they're trackable as well. But if I just wanted to only have the main ship's trackable, then I'll just take that component out and it works. So don't mind all the uncommented code, but just one thing that I've added in very quickly here was just some of this, the mining code. So all that was is literally just this piece of code over here. It's a little bit messy at the moment, so I really need to think about how to do this a little bit better. But basically, like, you have to capture all the components that you want and then work on them. But obviously, if you cycle through your objects and some objects don't have the full component list that you want, that's not a valid object anymore for this calculation set. So you need to make sure you skip over that object or ID or whatever you want to call it in your loop. So that's basically, I've just written a quick macro that, you know, if it's a null pointer, then just go to the next element in the what's it called, in the old loop. Where were we? So yeah, I mean, it's relatively straightforward. You just capture all the components that you want, and then you just do the calculation. So all I did here was I said, okay, if the drone has inventory space, then if the owner of the drone is near an asteroid, then go and mine it. Or if it's near what I've called a mineable, which would be an asteroid, maybe planet, whatever, the drone will go and mine that bad boy. But if not, then it just follows the owner. And then if its inventory space is full, then obviously it has to go and kind of dump that in the owner's inventory space. You'll notice I've also got this thing called a global debug string list, and that basically just allows me to capture any variables that I care about just on the side of the screen in yellow, I believe. So if we just run, I'll show you what I mean. So these are the variables on the left hand side there that I just want to check at any moment, and because it's a string, I can just throw in whatever I want there. And that's one of the only areas where I'm actually using like C++ code. So, you know, the C++ string functions, which, you know, just make life so much easier, rather than kind of trying to write my own there. But yeah, so what you can see here is just a bunch of information about like at least one of the drones that's following the ship. And the reason why I put that up this time around was, as you get close to an asteroid, I think about 4,000 units away, then you see these additional fields here, which basically say the information about that asteroid, and more information about like the minerals, about the current drone that's being analyzed, and the ship itself. So, and there we go. Got through one of the asteroids, and now the drones are moving on to the next one. If there's another one in the 4,000 units of limit distance. And that's mining. So it's very easy to add. As you can see, I only had to add in a few additional components, and then not that much additional code. Where are we here? So all I needed to do was add in an inventories, add in some additional like thought into the brain code, like thought processes for the drones, and then just making sure that they always know how to swap back to their owner if needs be, and who their owner is at any point in time. So you can swap the target that the drone is targeting from the asteroid back to its owner, because otherwise it kind of loses who its owner is. So yeah, anything else on this one? No, already. That's kind of the whole thing. So what I want to go through is the actual elements code. I'm going to go through this relatively quickly. I'm going to put this up on GitHub and I'll add the link as well. But basically, I think the best way to think about this is that it's just simply an array, nothing really more than that. But I've just kind of made it relatively generic, such that I don't need to go and make a different version of these for each different type of like component that you could have, because it allows for the different sizes of different component types. It's all the code automatically allows for those different, like you could create right now, just quickly go and create a new component type, and basically you don't have to really worry about it not fitting into the structure. The only thing you have to do is a little bit of upfront work. At the moment, the way I've got it set up is you just have to make sure that the element type that you care about is in this list. So if you add in a new element type, which I just recently did on Minables, then you need to do that, and then you also need to just set up the actual table for that component type. But that's all the setup code you have to do. Otherwise, it's all kind of pretty straightforward. So just looking at the elements code as it stands. So basically what you can do is you can get from each of the tables that you have. If you've got a pointer that sits somewhere in that table, you can just get the ID for that like element. If you're working through an index, like a for loop, you can get the different pointers in that table to the different like rows in that table, so to speak. Or you can get the different IDs for each row. And the way I've set this up is kind of I split the tables into two components. I split the tables into the IDs as one series of like structures or rows, and then like a like for like series of rows for the actual information that or within each component for that table. So it's a little bit difficult to explain exactly what I mean there very quickly, but the reason why I've done that is that you can separate out the ID part, which is kind of generic and is exactly the same thought process, at least for every single kind of component, and then the actual data part of each component, which can differ depending on what component you're looking at. So one is fixed and one's variable, and I wanted to keep those two separate because then it kind of simplifies the code and also the way to think about it. So if I look at basically what I have here is kind of an area in memory that you can set up front, that for each when you create a new elements table, you just have to tell what size each element or that variable part of an element is going to be, and then what this does is it just sets up the relevant space in memory for elements of that type, and then you've got that space set up. You don't really need to ever do anything again. There's a hard cap on how many elements you can have per table, and that's obviously something that will need to be thought about over time, but at the moment I've got 64,000 rows per table, so that should be enough for the kind of games that I'm thinking of making, at least. So that's how you kind of set up your data area, and that data, again, that data is all set up in one particular space in memory that's kind of allocated right at the beginning of the application startup time. So there's no kind of memory allocation or anything that's going on here, new memory allocation. It's all sitting there waiting to be used, and then you kind of just poke into it and decide which chunks of that memory are going to be allocated to which tables, and then you kind of just go from there. The nice thing about that is it allows you to, like, you've got this relatively large set of space in memory. So what you can do is at initialization, you can set up like parts of that up front to tables that you know you're going to want up front. But if for whatever reason you want to add additional tables over time, then theoretically that's possible. That's not really something that I've kind of thought about, but theoretically that's possible. As long as your overall memory space can contain those tables. Now, if I look at the actual the remaining functions that actually kind of you can use for each table. So obviously you can get those pointers or IDs for different elements, and what you can also do is set individual elements within the table to be removed over time, and I'll go through that in a sec. But basically, it's how these tables work is they always have to be in sorted format. So the IDs within each table have to be sorted. It makes retrieving the various rows or IDs or doing lookups on those IDs that much quicker. So I like it to always be in a sorted format. And because of that, the one issue there is my insert function is obviously well, I haven't really thought too hard or done too much on it, but at the moment, if you want to insert an ID that's kind of not going to insert at the end of the table, then you have to kind of now move up a bunch of your table down to allow for the new ID to keep things sorted. And that is, well, first of all, can invalidate pointers, and second of all, it's pretty slow. So I've got a few ideas on how to fix that, but I still need to think about that. The main idea I have is you actually set up 2 tables per table. One is sorted and one's unsorted, and then you kind of slowly over time, as the game engine has spare capacity, you slowly fill the unsorted part into the sorted table, as and when you have time to do so. And the nice thing about that is that you get the benefits of an unsorted table most of the time, and then a sorted table most of the time, and then there's the unsorted part. Kind of doesn't pollute the sorted table and until you actually have time to ensure that your table is fully sorted. And then you just do kind of a linear search on that if needs be. Yeah, I think that's about it. I don't think any of the code is too super interesting. But yeah, just conceptually I wanted to kind of mention what was going on there, and I think it took me a little while to set it all up and to think about how to set it all up. But what I really like about it is that now adding in new components into the game seems to be pretty easy. And maybe it'd be as easy if I was using like a typical object-oriented approach or whatever. But this just feels neater. It feels like feels pretty intuitive, easy to understand, and also when I'm looking at just like my minables or asteroids as an example, or in this case I think I just did looking at the here we go, so the minables, right? I don't have to look at every single object in the game to search over my minables. They're all in one table, all just and neatly in one table that I can iterate through, rather than having to iterate through say drones in this case to see if they're a mineable or not a mineable. Here they're all just kind of already in this table. So I thought that was pretty cool. Yeah, so if you guys have any questions, I'm gonna try do a few of these. I'll probably go into individual components. That might be quite interesting. Um, once once they actually have anything worth talking about. I mean, this is the entirety of the AI at the moment for the drones, so obviously not a lot going on there. But yeah, if I guess if I you know create anything that's of interest or might be of interest, I will put up a separate video on those. Some of the physics code I think is quite cool. Um, I guess maybe some of the rendering code or shader code could be quite interesting as well. So I'll have a think about that, and if you guys have any thoughts on what you'd like to see as well, let me know.